Today I will discuss the temperature rise test of oil and winding. Temperature rise test of transformer oil. A transformer rise test of a temperature rise test of transformer is an important test which should be included in any type test of an oil transformer. The oil temperature rise test of transformer is very important. In this test, we check whether the temperature rising limit of the transformer winding and transformer oil is as specified by the manufacturer. Check whether the temperature rising the limit of the transformer winding. And next portion is procedure of temperature rise test for transformer oil. How to test a temperature rise test of transformer oil? The first procedure, the first the LV winding of the transformer is short circuited. First we will do the short circuited to the secondary side or low voltage side. Second procedure, then the then the one thermometer is placed in a pocket in the transformer top cover. Other other two thermometers are placed at the inlet and outlet of the cooler bank respectively. Though the one thermometer is placed in the pocket in the transformer top cover, and other two thermometers are placed inlet and outlet of the transformer. Third procedure, the voltage of such value is applied to the high voltage winding. The power input is equal to no load losses plus load losses corrected to a reference temperature is 75 degree Celsius. The voltage of such value is applied to the high voltage winding. The supply voltage is applied to the high voltage winding and low voltage winding is shorted. The power input is equal to no load losses plus load losses. The input power is equal to load losses plus no load losses corrected to reference temperature 75 degree Celsius. The fourth procedure, the total losses are measured by 3 wattmeter method. The total loss are measured by the 3 wattmeter method. Number 5, during the test, the hourly reading of top of top oil temperature are taken from the thermometer already placed in the pocket of the top cover. During the test, the hour will take the reading after 1 hour or hourly. We will reading the hourly of top oil temperature are taken where the thermometer are placed. Number 6 procedure. The hourly reading of the thermometer are placed. The hourly reading of thermometer are placed at inlet and outlet of the cooler bank are also noted to the the calculate the mean temperature of the oil. The one thermometer are placed top of the transformer. Other two other two thermometer are placed inlet and outlet of coolest bank. Number 7 procedure. The ambient temperature is measured by means of a thermometer are placed around the transformer. The ambient temperature, we will measure the ambient temperature by the thermometer. The thermometer are placed around the transformer at the 3 or 4 point situated at a distance of 1 to 2 meter from and halfway of the cooling surface of the transformer. Number of thermometer are placed from the transformer within 2 or 3 meters. Procedure 8. Procedure 8. The temperature rise test for top oil transformer should be continued. The temperature rise test for top oil transformer should be continued until the top oil temperature has reached an approximate steady value. We should be continue the procedure until an approximate steady value. That means the testing would be continue until the temperature increment of the top oil become less than 3 degrees Celsius in 1 hour. The temperature will increase the 3 degrees Celsius by 1 hour. This steady value of the top oil is determined. This steady value of the top oil is determined as the final temperature rise of transformer insulating oil. The steady value of the steady value of the transformer oil determined as the final temperature is of transformer insulating oil. The second point is winding temperature rise test of transformer. Winding temperature rise test of a transformer. When a transformer connected to the supply or their supply is high voltage, the temperature will increase in the winding. How to test the increase in temperature of transformer winding? We will take some procedure for test winding temperature rise. Number 1, after complete of a temperature rise test for top oil of a transformer, the current is reduced to its rated value for the transformer and is maintained for 1 hour. After the complete of temperature rise test for the top oil transformer, the current will be reduced and the transformer is maintained for 1 hour. Second point, after 1 hour the supply is switched off. After 1 hour the supply is switched off and short circuited, and supply connection to the high voltage side and short circuit connection to the low voltage side are opened. All the connection of transformer will remove. The third procedure, but the fans or pumps are kept running. But the fan and pumps are kept running because for cooling purpose, the fan and pumps are provided to cooling the transformer. They will work for cooling the transformer. The number 4, then the resistance of winding are measured quickly. Then the resistance of winding are measured quickly. Number 5, but there is always a minimum 3 to 4 minute time gap between first measurement of resistance. We will take the minimum 3 to 4 minute of the time gap between the measurement and the instant of switching off the transformer, which can be avoided. Number 6, the resistance are measured at the same 3 to 4 times interval. We will measure the resistance after 3 to 4 minute time interval over a period within 15 minutes. So that is the procedure of winding temperature rise test of transformer. The second test is back to back test on transformer. The transformer is another method for determining the transformer efficiency. Back to back, it is used for determining the transformer efficiency. The voltage regulation and heating under the loaded condition. Voltage regulation and heating under the loaded condition. The short circuit and open circuit test on transformer can give us the parameter equivalent circuit. The short circuit test and open circuit test transformer are provide the equivalent circuit or parameter. Here I will do the back-to-back test on the transformer. This back-to-back test of transformer give the test on transformer can give us the parameter of equivalent circuit on transformer, but they cannot help us finding the heating information. The back-to-back test the help us the finding the heating information. We we will take some procedure for doing the back-to-back test of transformer. The back-to-back test can be employed only when a two identical transformer are available. The back-to-back test can be employed only when the two identical transformer are available. Here the need for back-to-back test the two transformer. The both transformer are connected to supply. Both transformer connected to supply such that one transformer is loaded on another. The primary of the two identical transformer. The primary of the two identical transformer are connected to parallel across the supply. But secondary are connected in such they're in series connection. The secondary is connected in series such that EMF of them other the two secondary side of the transformer are connected in series. Therefore, the EMF of both transformer are opposed to each other. And another low voltage is supplied the connected in series with the secondary to get the reading. So the circuit diagram below. This is the circuit diagram of back-to-back test of transformer. Here the two transformer are identical. The primary side and two are secondary side. The primary side connected to the supply in parallel, and other side is the secondary is connected in series. Here the two wattmeter, the wattmeter on here the connected the wattmeter on the input for reading a input power, or here the wattmeter to reading a output, and the ammeter will reading a current. Here the another transformer is connected here connected to provide a low voltage supply, and the low voltage supply is connected in series with the secondary. Here the secondary induced EMF, both the EMF are cancelled. The cancel the each other as the transformer are identical. In this case, as per the superposition theory, the no current flow through the secondary side because their EMF is the EMF opposed to each other. Therefore, the no current flow through the secondary side, and thus the no load test is simulated. The current drop from V1 is to ion 0, where the I0 is equal to the no load current of each transformer. Thus, the input power is measured by wattmeter W1 equal to is loss of both transformer. Here Here the wattmeter is W1. It measured the input power. It measures the input power. Here the another wattmeter is measured the output power. The input power, the thus the input power measured by the wattmeter W1 is equal to iron loss of both transformer. The W1 is measured the iron loss of both transformer. Therefore, the iron loss of one transformer is W1 by T. That is, the iron loss per transformer is W1 by T. Now, a small voltage V2 is injected to the secondary. Here, the low voltage is supplied by the transformer T to inject to the secondary side. Inject to the secondary side with the help of low voltage transformer. The voltage V2 is adjusted so that the related current I2 flow through the secondary side. So the related current I2 flow through the secondary side. Here the current I2 flow through the secondary side. There is current will be the secondary side is 0. In this case, the both primary and secondary carry a rated current. Thus, the short circuit test is simulated the wattmeter W2 so the total full load copper loss of both transformer. To measure the full load copper loss of both transformer, that is the copper loss per transformer is equal to W2 by 2. For the above test result, the full load efficiency of each transformer can be given as this is the formula of full load efficiency of each transformer. That is the output by output plus W1 by 2 plus W2 by 2. It is the iron loss. It is the iron loss for each transformer. It is a copper loss for each transformer. It is the procedure of back-to-back test.